In our house, sometimes our light doesn't work and the receptacle doesn't work. Even we plug in a brand new appliance, it still doesn't work. And we use proximmeter to test it. It shows the circuit is live, the receptacle is live. We use plug tester, it shows open neutral. Why? What is open neutral? Open neutral is little bit tricky. This problem sometimes is hard to fix. Okay, what is open neutral? First, let me explain the electric system in our house. In our house, there's an electric panel. Inside this panel, there are dozens of the breakers. This is one of breaker. The breaker connects to black wire, which is live. Okay, black wire 120 VEC, live. We also call it hot. I mark with L here. Sometimes we mark with L here. There's also another wire which is white. They connect to neutral. Here marked with N, and blue wire, blue in color. See, actually this is white wire, 0 VEC, neutral. There's another wire, it's paired copper. It's connected to the ground bar in the panel. And then the paired neutral go to the switches, the light, the receptacles. I mark the paired copper wire and gray here. It's ground wire, 0 VEC, paired or gray. In residential, generally we use 214 Romex cable. The 2 stands for 2 wire, 14 stands for American wire gauge 14. It's the wire size. It said 2 wire, actually it's 3 wire, because there is black, which is hot, there's white, which is neutral. There's also a paired copper wire, which generally will be connected to ground. If everything is fine, we turn this switch on. The light is being on. We turn this switch off. The light is being off. We plug our appliance here. The appliance can work. Okay, see, 120 goes to here. Okay, all the way. Here, 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 here. 120 go to here. If the switch is closed, the 120 goes to here, and then come to the light, and then the current goes through neutral back to panel. It became a closed loop, or called closed circuit. Let's say the receptacle. Okay, the 120 come to here, and come to here, come to here. If here we plug something here, right? We plug a vacuum cleaner, a coffee machine here, right? And then the 120 come to here, and the current goes through the neutral wire back to panel. So if everything is fine, all the lights, receptacles are going to work fine. See, the light working fine, the light working fine. The appliance we can plug here, 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 anywhere. It's going to work, right? Let's say if there's a broken point here. Okay, see, the 120 come to here, come to here. If the switch is closed, come to here, and come to the light. And then the current goes through here. Because here it's broken, right? Here it's broken. The current cannot go through. So no matter the switch is on or off, the light doesn't work. Even you change a brand new light bulb, doesn't work. And we use proximmeter measure here. If the switch is closed, the wire is live. And mirror here, if the switch is closed, the wire also live. We use multimeter mirror here. If the switch is closed, it shows 120. Use multimeter mirror between here and here. It shows between the live and neutral. It shows 0. Mirror between neutral and ground. It shows 120. Mirror between live and ground. It shows 120. So, if the switch is closed and the neutral seems live and the voltage meter shows the voltage between live and neutral is 0 and neutral and ground is 120, that means the current cannot go through, right? Here 120, right? So this will look like. So this is the open neutral. How to fix the problem? We have to find the broken point. From this drawing, we can know the broken point is here or here. If here it's an inside light fixture, we open the light fixture, we can find it, and we probably the wire is loose or disconnected. We reconnect, and that's been fixed the problem. If it's here, we have to find where it is, where this point is, right? Possibly it's inside the junction box, or another switch box, or another light box, light fixture, or another receptacle box. So we have to find it. Okay, let's see this. If it's broken here, what's going to happen? The light is working fine. This is receptacle working fine. This is receptacle working fine. This is receptacle working fine. This receptacle doesn't work. We plug a place here, it doesn't work. But plug it here, plug it to here, plug it to here, all of them working. So this receptacle have problem. We measure with the plug tester, it shows open neutral. We measure with protometer, it shows live. We measure with multimeter, it's going to show the voltage between live and ground is 120. Voltage between live and neutral is 0 if we plug the machine on. If not, no appliance plugged here, the voltage between live and neutral are going to show something between 0 and 120, right? A weird number. Because see, here is broken, here is broken. This the ground voltage is 0, but here is not grounded, right? So the voltage we don't know. It should be less than 120 and higher than 0, or equal to 0. We don't know, right? So it's going to be a weird number. And measure between here, the neutral and ground, also a weird number between 0 and 120. So this is also open neutral. In this case, we have to find the broken point. The broken point possibly is behind this receptacle, or somewhere behind this receptacle, or behind this light switch, or this light. So it's hard to see, or a junction box somewhere. So it's hard to see. Okay, so you have to find a box nearby to check it. Possibly there is a loose white wire or broken white wire, disconnected white wire. Okay, let's see this. If the broken point here, what's going to happen? See, the voltage goes to here. So this light, voltage goes to here. If the switch is closed, go here. and go here and go back to panel. The voltage go to here, right? If here plug an appliance here, the voltage goes through neutral and come back to panel. This light, same thing, working fine. How about this receptacle? See, the voltage from breaker come to here and come to here, and they come here, come to here. So the live wire is live, right? And if we plug a place here, and then the current goes to here, and they come back to here, boom. Because here is broken, right? So the current cannot go back to panel, cannot become a closed loop. So this receptacle doesn't work. And this receptacle doesn't work also. This receptacle does not work also. So we measure with plug tester, it shows open neutral. This also shows open neutral. This also shows open neutral. But this shows working fine. We use proximeter, it shows live, and this also live. We use multimeter, we measure it here, the live wire and neutral wire. The voltage between live wire and ground wire is 120. If we plug an appliance here, because the appliance here, so the voltage comes to here, right? So the voltage between live and neutral is 0. If no appliance plug here, but the appliance plug here, see this neutral connect with this neutral, right? This neutral connect with this neutral. So here we can get 120. Here we can get 120. Here we can get 120. Right? We measure the voltage between live and neutral, shows 0. Live and neutral shows 0. Live and neutral shows 0. And neutral and ground is 120. Neutral and ground 120. Right? And live and ground is 120. If we plug something here, if we did not plug, we plug nothing in this three receptacle, one of these three receptacles, it shows the voltage shows here is live, but here, because here, see, here is broken, right? Not connected. So the voltage between live and neutral is something between, the number is something between 0 and 120. The number is something between 0 and 120, right? Here, same thing. And the voltage between live and ground is 120, live and ground 120, but neutral and ground is, the number is something between 0 and 120, right? Because nothing plugged here, right? Here is not connected, here is not connected. So we are not sure what the voltage is here, right? Because here is broken. So if the broken point in the main branches of the neutral, there's going to be couple of the receptacle light that not work. So how to find the broken point? Possibly the broken point is here, or here, or here, or here, or here, or here, even the here, or here. If you are lucky, you can find it in half hours. If you are not lucky, you spend a couple of days, you still can get the job done. It's time consuming, right? You know the problem is, you know what the problem is, but it's hard to find the broken point. Really hard. Maybe you have to open all of the receptacle and light fixture and switches in the house. You know, we always do renovation after a couple of years, we are going to do renovation again. After a couple of years, we are going to do renovation again. And the electrical contractor are going to run the wire here and there, here and there. Sometimes, the wire is too short. They are going to install a receptacle and leave the receptacle behind the driveway. You cannot see. You don't know. You cannot see. So in this case, no matter how many hours you spend in the job, you cannot fix it. So how to do it? We run a neutral wire from here to here, or from here to here, from here to here, or from here to here, or here. Whatever is convenient to you, you need to have a neutral connector, right? This is open neutral problem. The open neutral problem, it's kind of tricky, right? Sometimes hard to fix it. Sometimes it's easy, depending on the location, right? Okay, this is my explanation of open neutral. If you have any question, leave on the comment. Thank you.